Dividing next the types of work done. The second type of work done, which we are going to say, study, is actually negative work done. So if you have been taken the negative work done, all of you observe, when the angle between the force and the displacement of the body is obtuse angle. Obtuse. What do you mean by obtuse? Anybody? Yes, please.
More than 90 degrees, less
Yes.
than
More than
180.
90 and less than 180. That is what obtuse. So that is the mathematical relation, mathematical terms which we'll use it. So all of you remember the applied force and the displacement, the angle between them is between 90 to 180 degrees. Then that is the work done, which we used to call it as a negative work done. Okay. So now let us see what kind of examples we'll take it and we'll try to do it. So if you observe here, in these cases, you can write it, the angle between the force and the displacement. The angle between force and displacement. So displacement means object is in what? Motion or state of rest? Everybody. Object is showing the displacement. Means it is state of motion or state of rest? State of motion. Do you understand? Motion of a body is actually what? Obtuse. Means it is varies from 90 to 180 angle. So here in this case, so what will happen everybody if I take cos theta? So note it everybody, cos theta if I take, for example, if theta is equals to 180 degrees. So cos 180 how much everybody? Check it, verify it all of you. Cos 180, yesterday's class I have given the tabular column. Cos 180 is equals to how much? Yes, please.
-1.
-1. Then
-1.
work done is equals to Shivani. Last 1 week, I think 10 days. All the videos you have to watch, except day before yesterday video. I have uploaded everything. You have to follow up whatever it is, and you have to make everything ready by this Saturday or Sunday. Okay.
Okay, sir.
Yeah. So work done is equals to, you can see, minus of force into displacement. So remember here, this minus is not belongs to force or displacement. What minus represents, what minus indicates, that is allowed you have to treat. What minus indicates, everybody? Minus indicates, yes, minus indicating force and displacement are not in the same direction. They are in the what direction? They are in the opposite direction. That is the meaning of minus. So negative work done. So those who are joining late, after 20 minutes, 25 minutes, if you join in the meeting, what is the use? You have to be in time. So for example, if I take, there is an object, you imagine. There is an object. So now I am applying the force. I am applying the force with the inclination. See that theta. Theta is more than 90 or less than 90? Everybody. More than 90. So this is what is the direction of force. So now object is at A. Now it is started moving in this direction. This is the motion. So now you can see displacement is in this direction, but force is in this direction. So it is a negative work done or positive work done? Everyone.
Negative.
Negative work done. That is what you have to remember. So examples of negative work done. So the best examples for negative work done is what everybody?
Archery.
Yes. Archery, sir. Archery you cannot be married. That is okay. You let us.
And bow and arrow. Bow and arrow.
Yeah. So we'll discuss it. Don't go to complicated example. Let us study the simplest examples. For example, let us start with the first thing. So if you take it, a ball is rolling on the ground. a ball is rolling on the ground. You all knows nobody is applying the force. Imagine just a ball is rolling on the ground. This is what is the motion. Now there is a force which is acting something in the backward, opposite direction. What is that force? You all are very familiar with that force.
Frictional force or drag force.
Frictional force. That is acting what direction? All of-
Opposite direction.
Yes. Frictional force. So here, work done by the frictional force is always what? Opposite to the direction of motion. So it is both are negative or positive? Both are opposite. So negative. Do you understand it? Negative work done. Clear, everybody? Understand, Agalya? Yes? So that is what you have to remember. Next. First example. So go with a simplified example always. Now, if I have thrown the ball upward direction, the direction of ball in upward direction, but there is a force which is pulling force always acting downward direction.
Gravitational force.
Gravity. So now also you can see gravity is acting downwards, but the motion of the object is in upwards. So that is what is the another example. Or else you can take. So, or else as I said, cos 180 is -1. So what does it mean? So exactly like you imagine, opposite. The motion of the object is forward direction, and the applied force in what direction? Everybody. Applied force exactly in what direction, guys? Opposite direction. That is what is actually, what is the angle between them? Anybody?
180.
180 degrees. Okay. So that is what. Yeah, slidings in circus and whatever. So now, or else if you take, there is a car. See, with the visualization, if I am giving the example, so that you people can make a sentences. First, see, class 10th, many difficulties are facing by people. Class 11th and class 12th also. The major problem is what the poor imaginatory skills, or see, physics means imagination. More than what we can say is experimenting. First thing you have to experience the physics, visualize like a self visualization. So that's the reason always physics we can say is a nature. Physics means nature. So you should learn with the interest and observation. So if I take car, so now always we know our car will move forward direction. That is what is in motion. Now I want to stop my car. So definitely I need to apply the force in what direction? Everybody.
Opposite direction.
Opposite direction. That is the force we used to call it as a, what force we used to say? Brake force. Am I right? All of you? So the force applied, brakes are applied on a moving vehicle. The work done by the braking force. Actually, it's not a braking force, brake force. The force applied by the brake force. Okay. So that is what you have to remember. So this is an example of what? Negative work done or positive work done? Even we can say in this, it is actually a what? Deacceleration. Deacceleration. Okay. Or we can say negative acceleration. Okay. Or perfect word. What is the perfect word?
Retardation.
So retardation is also example of negative work done. Do it everyone. Now, Padma is asking some question. Sir, when I am moving in an object in north direction and frictional force is acting in the southward direction, but the displacement is in the north direction, is it positive work done or negative work done? Remember, for example, all of you listen. Now, for example, there is a toy car. I am applying a force in this direction and the displacement also in this direction. Now, the work done by this force, the work done by this applied force, Purima, Mari, the work done by the applied force is equals to positive. Okay, va? Ellame understood, amma?
Yes, sir.
Yes. But whenever you are moving the car forward, but still there is a force which is acting backward direction. That is the force we used to call it as a, what force we used to say? Friction.
Frictional force.
Then
Frictional
work
force.
done by the frictional force, which is equals to what?
Negative.
Do you understand now, Padma, your question?
Yes, sir.
Sir,
Yes.
so if only in the question
Listen,
paper if there
everyone.
means
Yes,
negative.
you have to specify it. Be very careful. Every moving object, work done by the frictional force is always negative. Do you understand, everybody? Are you clear?
Yes, sir.
You have to specify either it is applied force or it is the frictional force. Clear?
Okay. Yes, sir.
That is all. So please remember that and do it. Any doubt, you have to ask me. Clear, everybody? Alfin, Abrami. So examples. So these many
Yes,
examples already. So learn it and do it. So you have to remember mainly negative work done means scientific words obtuse angle, and angle is varies between 90 to 180. So these are the two terms which you need to remember so that it is very easy to make it. Next one. Next, third type of work done. What is the third type of work done? Everybody?
Zero work.
So, yeah. Zero work done. Okay. So zero work done means, remember, the angle between force and displacement is exactly 90 degrees. $90. Clear? So then work done is what? Everybody. Work done is equals to how much? 0 joules. Okay. So why? If theta is equals to 90 degrees, speak in a mathematics way always. Then we all knows that cos 0 is cos theta equals to cos 90. So cos 90 value how much? Pakranga, table or column. Cos 90. Cos 90, 0. So Fs cos theta. So Fs cos 90. So cos 90 is 0. So F into S into 0, which is equals to 0. So total work done is what? 0. Prima. Understood, everybody?
Yes, sir.
Yeah.
Yes, sir.
Clear, everyone?
Yes, sir.
Any doubt you can ask. Okay, everybody? So this is what is negative work done. Sorry, zero work done. Or you can see this is for what, everyone? The applied force. See, applied force is perpendicular. So if I take, for example, this is the surface. Now the motion of the surface is this. Object is in this direction. And applied force is upward direction. Angle between them. Suppose this is the object. Now, the angle between them is how much, everybody? 90 degrees. Clear? So, in this case, work done by the applied force applied is equals to 0 joules. Am I clear? Do you all understand, everybody? Or else,
Yeah.
work done is equals to, another definition also is that. Another means, if either, this is also very important, either force or displacement. Force or displacement is 0. Any one thing. Or both 0. Both 0. Then also work done is what? Everybody. Then also
0.
0. Work done is 0. See, this much slowly, neatly, clearly teaching, the only purpose is you have to understand and carry it forward for the future. That is the importance, because work and energy, class 11, volume 1, chapter number 6, chapter 6, work, energy, power. So that much importance. If basics are not clear, understanding concepts is very tough in the class 11th. If you are go with the proper fundamentals, I'm saying you, there you will rock. Whatever the toughest concept, doesn't matter. You will easily will understand, because you are already, your mind is already tuned accordingly. That is the only advantage for the people who are learning and going, who are directly going to 11th. That's why I'm saying whatever you are learning, you have to remember also. Simply today I learn, tomorrow I'll forget means no use. So because it's the interconnectivity, all the chapters are interconnectivity. So that's why you must have a habit of understanding from this age, 9th onwards it is. See, it's whatever the competitive exam, whatever you try, minimum 4 years of continuous hard work. Even for you, almost 1 year loss, 9th class also over. So that's why consistently 4 years minimum you have to work for it. Then only it will be something good. So please plan accordingly and do it. So this is what negative work done. So let us go with the examples. Examples. The best example, last class, last unit, what we studied is actually gravitation. Am I right, everybody? All of you? Yes. So many beautiful concepts we have studied in gravitation, and I have taught you many important phenomena. So, work done by the centripetal force. Centripetal force only we used to call it as a gravitational force. Am I right, everybody? Please respond, guys. All of you?
Yes, sir.
So always you remember, towards the center. The force which is acting towards the center is always a centripetal force. That is what I will take it as a FC, centripetal force. But at every point, the direction of motion is perpendicularly to that. At every point, it is a perpendicular. Direction of motion is always perpendicularly to the centripetal force. Yes, Amma. Agalya, you are exactly correct. Then according to the normal force of any body, work done is always 0. Yes, the normal force is never impact on it. Only it will equals to weight of the body. Understand? That is also above from the ground. Okay, Agalya?
Yes, sir.
Yeah. So, angle between them, the direction of motion and centripetal force, anything. This is the concept which I spend more time and I have taught you. At every point, direction of motion and any direction you take, at any point, direction of motion and the centripetal force. What is the angle between them, everybody? What is the angle
90.
between them? 90 degrees.
90.
Both are always perpendicular to each other. So, the work done by the centripetal force, which is equals to always 0. Okay. Why? The angle between them is what? Yes, please. 90 degrees. Remember, the centripetal force is acting towards to the center along the radius. Along the radius of the circular path. Extremely important point. Okay. In class 11th, again, chapter number 7 in volume 1 is gravitation. Note it, whatever I taught in gravitation, you go with that knowledge. 30% of 11th class is already almost, you are very strong. That much deeper we have been studied. So there you will experience it. What is that? If you are going really with the complete knowledge. So what will happen always, everybody? Centripetal force acts always towards to the center along the radius. And the direction of motion is always perpendicular to it. So the angle between them is always 90 degrees. So 90 degrees means what is the work done? Everybody.
Zero.
0. That is what is the first point. Write it. Work done by the centripetal force. Work done by the. Nivedan, understand? Lingesh?
Yes,
Work
sir.
done by the centripetal force. Hey, Kishore, are you there? Centripetal
Sir.
force on a body moving in a circular path. Moving in a circular path. Circular path is 0. Why it is 0? Because the angle between the F and S is what? Yes. Angle
90.
between centripetal force and S is 90. So cos 90 is how much? Cos 90 is everybody 0.
Zero.
So work done is equals to Fs cos 90. So which is equals to 0. Clear? And you write it. Always centripetal force acts what? Centripetal force is acts along the what? Everybody.
Radius.
Along the radius of the circular path. I hope you all clear, everybody. Yes.
Yes, sir.
Yeah. Clear?
Yes, sir.
Any doubt? Anybody can ask. I hope everybody understood. Rudve, Sam.
Yes, sir.
Okay, good. Do it fast. Kavya, very, very late, Kavya. Okay, next example, right? Okay, va? Everybody? Hasani Sudhakar. Okay, ma, understood?
Yes, sir.
Do it. Next example. What is the next example, everybody? A person is walking on a road. So, write everything. Next example. When a coolie is walking on a horizontal platform, when a coolie is walking with a horizontal platform, so for example, so we all know the platform will be like, we can imagine like a three-dimensional.
So who is walking on the platform, sir?
Coolie. Railway coolie or normal coolie. Labor, we'll say this is castle. It is. It is there, Abhirami, that all the values, but you will study in only 12th class. How to calculate other values. Listen, everybody. Cos values, only particular values I have given. Remaining values, for example, if you want to calculate cos 38, cos 25, these are all values. How to calculate, you will study in class 12th. So by the time you will understand. That's why now only perfect values, which is already well known to everybody, I have given. Remaining all you will learn in mathematics how to calculate it. So then you can do it anything. Okay. Okay, understood? All of you?
Yes, sir.
Yeah. So now imagine the displacement, his motion. It's a three-dimensional. Okay. So x-axis, y-axis, and z-axis it is. So now Mr. Railway Coolie is carrying a load in his head, and he is walking in this direction. That is what the motion. So now The applied force, he is applying the force to carry the load in the upward direction. That is what is the force. So now, if you have noticed it, what is the angle between them? Whatever it is, if you take three axes, z axis, x, y, z, basically it's a two-dimensional plane to represent the three-dimensional. So if you take anything, what is the angle between them? Everybody? Applied force, 90 degrees.
90.
So when a person is walking in a platform, horizontal platform with a heavy load on his head, he applies the force on the load in what direction? He applies the force on the load. What to hold the load, he has to apply the force in what direction? Upward direction. Okay, clear? That is whatever. How much force he is applying? That is what is my question. Anybody can tell? That is my intelligent. That is one of the intelligent question. Let me see who will answer. How much force he is applying? Anybody?
X.
No, Mari. Please be
The
logical.
force equal to the weight.
Who is this?
Shivani, sir.
Shivani. Very good. Wonderful. Everybody. So that is what it is. For example, that is very good, Shivani. Really super it is. So the force applied by him is equals to what, everybody? Equals to weight of the load. Do you all understand, everyone? Clearer? Yes, please. All of you?
Yes, sir.
Yeah. So that is what I'm asking you. So he is applying the force in upward direction, which is equals to the what? Which is equals to the weight of the load. Mario, do you understand how to think? Be very careful. Clear? Yes. So it's nothing wrong in that. Then, while the displacement is in the horizontal direction, he is moving in the horizontal direction, but he is applying force in the upward direction. Then what is the angle between them? Everybody, force and displacement, what is the angle? Yes, please. Force and displacement, what is the angle? Perpendicular to each other. What is the meaning of perpendicular? Angle between them?
80 degrees.
90 degrees. So 90 degrees means work done is equals to what? 0. Okay?
0.
Because cos 90 is equals to 0. So that work done is equals to 0. Do it fast. Understand, Shivani? Kavya? Alfin?
Yes, sir.
Yeah, do it. Anything doubt you can ask.
Sir, force upward is equals to what, sir?
Force upward, not Mari. The force which is, he is applying the force in the upward direction. Am I right or wrong? Because he has to hold the load. Are you clear?
Yes, sir.
So now how much force you apply? For example, now you are imagine just I am putting some load on your head, Mari. So now first I am putting, for example, 1 kg. Now another time I am putting 100 kg. Now, do you think that both the cases, the force applied by you is in upward direction only to hold that load? Do you think that both the cases you apply the same force?
No,
Yes?
sir.
No. Because 1 kg means 10 Newton force. That is what 1 into 10, 10 Newton. So your applied force is 10 Newtons because the weight of the body is 10 Newtons. Are you clear what I'm saying?
Yes, sir.
Yeah. But in this case, the weight of the body is 1000 Newton. Then your applied force is also 1000 Newton. Then only you can balance it. Otherwise, the load will fall down. Are you clear?
Yes, sir.
Yes, that's all. Understood, Amma, everybody? All of you? Any doubt? Anybody can ask. Clear, Mr. Lingesh? Meeting is going to end. You can join back and we'll continue. Mr. Mukesh, okay? Niroshi? Do it, do it. Second exam, this is. Make it quick.